Just a quick reminder to you, if you are dividing things that have exponents, you keep whatever the base is and subtract the exponents. So if you take a look like a question on this one, it's bottom heavy, meaning that there are more x's on the bottom than there are on the top. And so when you subtract 2 and 3, the negative one that you get as an answer pushes the x to the bottom. Just a quick reminder that when you're multiplying or dividing, you have to have the same index. You keep the index and divide the radicands. Then you simplify if possible. So number 1, they are both square roots, which means that you keep the square root and divide the radicands. 27 divided by 3 is 9. X cubed over x is x squared. The square root of 9 is 3. The square root of x squared is x, with absolute values around the x because you started even and ended odd. Number 2, they're both square roots, so you divide. 100 divided by 2 is 50. Y to the 6th over y to the 4th is y squared. 50 isn't a perfect square, so you have to rewrite it using a perfect square. The perfect square of 50 that you would use would be 25. So make that the square root of 25 times 2 with the y squared. The square root of 25 is 5. The square root of y squared is y, which means you're left with the square root of 2. You did start even and end odd, so you need absolute values around the y. In number 3, if you take a look at the original problem, there are more b's on the bottom than there are on the top. And so when you simplify this cubed root, you're going to be left with a fraction. 16 divided by 2 is 8. A to the 4th over a is a cubed. And b over b to the 7th is b to the 6th. You should take a 5-second time out and make sure that everything in this situation is cube rootable, and they all are. So take the cubed root. The cubed root of 8 is 2, and it stays up top because that's where the 8 is. The cubed root of a cubed is a, and the cubed root of b to the 6th is b squared. That b squared goes on the bottom because that's where the b to the 6th is. No absolute values are necessary because you started odd. In number 4, there won't be a fraction under the radical because everything is top heavy. When you divide, you get the 4th root of 32 divided by 2 is 16, and y to the 9th over y to the 4th is y to the 5th. You do have to rewrite that, though. Even though you can take the 4th root of 16, you can't take the 4th root of y to the 5th. So leave the 16, but make the y to the 5th a y to the 4th times y. The 4th root of 16 is 2. The 4th root of y to the 4th is y, which means you're left with the 4th root of y. Don't forget you do need absolute values because you started even and ended odd, and you need an index of 4. Number 5. Number 5 will be a fraction underneath because both the 16 and the b to the 7th are bottom heavy. 2 over 16 reduces to 1 over 8, and b over b to the 7th is a b to the 6th on the bottom. 1, 8, and b to the 6th are all cube rootable. So the cube root of 1 is 1. The cube root of 8 is 2, and the cube root of b to the 6th is b squared. Wherever the original number started in the fraction is where it'll end up in the answer. Number 6 will not be a fraction. 24 divided by 2 is 12, and y to the 8th over y to the 3rd is y to the 5th. Neither 12 nor y to the 5th can be square rooted, so you need to rewrite them. I'm going to rewrite the 12 as a 4 times 3, and the y to the 5th, I'll make a y to the 4th y. The square root of 4 is 2. The square root of y to the 4th is y squared, which means I'm left with the square root of 3y. Even though I started even, no absolute values are necessary because I ended even as well.